Okay, so this is the office hour and on Tuesday, and we have a question related to what topic will be covered for the midterm, or what kind of concept that will be covered in the midterm. So I'm going to use this recording to kind of go over this. So if you can see on the screen, I'm going to CPP07. And I'm going to edit a file I call the midterm MT4. MT4 EC30, let me do this, EC36b, MT4, and then this is going to be, what should I do? MT4 concept, okay. .txt. Okay, so first, I want to say that we will cover some of the concept that's actually from the previous 3 midterm, but we will go a little bit deeper than the simple thing from previous midterm. For example, virtual function is definitely a topic I would like to go a little bit deeper than this one. Okay, so the virtual function concept in midterm 3 is kind of in a fairly simple form about the virtual function. So one example about the virtual function is we developed this in CPP09. So in CPP09, we introduce a class called shadow. We call it shadow GPS. And if you think about what shadow GPS, if you look at shadow GPS.h, oh, I have to go to CPP09. If you look at the shadow GPS.h, essentially all the function that's important for our operation is a virtual function. So you can see that the function has two virtual functions, which is set GPS label and dump to JSON. Okay, so this is a clever application of a concept of virtual function, such that when you apply a member function call, either is a dump to JSON or the set GPS label, because the object pointer has been casted to a different function pointer. So from the reading of the code, we have no way to tell whether it is a real object or it's just a proxy to a remote object.
Sorry, Bob, can you tell me what dump to JSON does? Okay,
dump to JSON is doing a transformation from a C++ object, the content of the C++ object, into a JSON format representation of the same object. So let me write it down here. So what is a dump to JSON? Okay, what's dump to JSON?
That's parsing in a way, parsing from C++.
No, it's not a parsing. Is essentially what is the C++ object? C++ object is essentially the C++ using some memory to be able to represent the information. Okay, so if you look at what the C++ object is, it's really whatever in the memory that you can find. Is an integer, is a pointer, or is another object. Okay, contained in another object. So that is what we call a representation of an object, right? You have an object, what it is really, because as a programmer, we need to know that representation in order to use the object appropriately. Okay, and of course, in C++, compiler is helping. So that's why the compiler has to know that, okay, where is the memory correspond to this particular attribute? For example, I want to find a sequence number for a thing object, which is a integer, then the compiler need to produce the code and such that we will calculate the address, the correct location to retrieve the value of that integer value, which is the sequence number. Okay, so that's basically the collaboration between the storage of the object and the compiler who generate the code to access that. That is a C++ representation about an object. Okay, the programmer need to know only a little bit about that representation. Particularly, you need to know, oh, I need to do this, pointing to the sequence number, and compiler will figure out the rest for us. Okay, that's a C++ representation. However, we can represent the same object, exactly the same content, using a different format. And that format is called JSON, JavaScript Object Notation. That's a different notation. It's called JSON. Okay, so JSON was initially developed for a particular script language called JavaScript. Okay, by the way, JavaScript is not Java. It's a different scripting language that can work with Java and other language. Okay, so when we transform this into a different format, so essentially in terms of the content of the object, they are equivalent. So one is representing JSON, one is representing C++. But JSON has some really nice property. For example, it essentially provides a linearization about all the information. So if you think about object actually have a structure. For example, if you have an object with a pointer, then that pointer is going to pointing somewhere else. So your information is not as simple as a consecutive bytes. Instead, you have a bunch of bytes here, you have a bunch of bytes over there, and their relationship is kind of like a spaghetti, twisted, mingled together. But JSON is a nice representation. It's readable. You can actually just read the JSON. You know what the object structure and the content of the object. But second, that it's a linearization, means that everything is contained together as a sequence of bytes without any hole. And then you can represent the whole object. And that representation, you can do a lot of things. So dump to JSON is just transform a C++ object into a JSON representation for the same object.
Why
So
was it's not parsing? Like, isn't that what parsing does? Like,
what do you mean by parsing?
like there's a parsing like operator function, right? Like converts like JSON format to C++ format.
Okay, there is only okay. I'm not aware of a standard function to parse the JSON to the C++ object. That's what we can develop, but that's not given. However, a typical JSON library, they have a parser. When we say a parser of a JSON is looking, if you provide if you give me a JSON, you claim it is JSON. You claim it is JSON. So essentially, when we got a JSON, because it's a linearization, it's essentially a string. It's a string of information. Yeah. So the parser is basically look at the string to see if, number one, whether this string is a valid JSON. So that's parsing to see if your syntax of JSON is appropriate. And if that's appropriate, it means that your parsing is correctly, it will generate a JSON object. So there is a JSON representation, which is in our case, JSON colon value. That's the JSON value. So there is a parser that's actually built in the library of JSON that will help you to convert any kind of string into a C++ JSON object. Okay, so you will see some of the example in the future, but that's not covering this exam. Okay. No, because I will just explain what is dump to JSON. So dump to JSON is a function that's generate the okay. So we're talking about virtual function for CPP09. So CPP09 is talk about proxy object. We even talked about that yesterday. But the main mechanism to enable the proxy is using virtual function. So we essentially say, hey, the programmer doesn't need to know whether this particular object he is trying to access is a local real object or is just a proxy for a remote object. And the thing is that it depends. This is called polymorphism, by the way. Virtual function is the C++ way of implementing polymorphism. So polymorphism means that, oh, the behavior of the function or the object is going to be different. And the programmer doesn't need to worry about that. Okay, if the programmer is aware about the difference, then essentially you're adding burden to the programmer. So the polymorphism means that it looks like it's the same object or the same function, but when you approach it, it's going to behave differently. For example, if you want to do it in the remote object, that's actually you will see that is try to contact the remote object, and if it's a local object, it's going to call the local object. Okay, so in the shadow GPS, you can see that on the screen. I'm sorry that you guys cannot. I just realized I'm using a different Zoom channel. But if you look at the shadow GPS.h, it has a two virtual function, which means that is going to use the virtual function mechanism to do that. Okay, just 1 second. Are you here for the makeup midterm?
Oh, no.
No, okay, don't worry. So just have a seat where I'm trying to answer a question. Okay, so that is the first concept about virtual function. So in other words, I'm going to ask you pretty much similar concept like what I asked you before, but now I'm going to ask you a question in the context of CPP 07, 08, and 09. And also, I will talk a little bit about, there is a CPP, sorry, I think it's a CPP 06 or 05 when I talk about the design about the, let me take a look at this. Yeah, I think that's a 06, right? Yeah, I'm going to ask question about 06 as well. Okay, so CPP 06, 07, 08, and 09. Yeah. So let me actually try to do my best to try to remember what are the important concepts. Virtual function is definitely one of the most important concepts. I will try to ask you. No, I'm not going to ask you any question about frame function. I haven't talked about frame function yet. Okay, so not in the frame function. I will cover. I would definitely want to cover single inheritance. Single inheritance in general, not multiple inheritance, but single inheritance is one of them.
So it's going to be the single inheritance.
Only single inheritance. We haven't covered multiple inheritance. Yeah. Oh, well, I explained a little bit. The last midterm, when I cover certain concept, I kind of cover in the most simple way. So I will still testing. First, I would like to test the older concept that you already covered in midterm 1, 2, 3. But now we're into a different context, which will be a little bit more challenging. I would like you to apply maybe to a different scenario. Okay, yeah. All right, so let me see what else I want to cover. Let me take a look at the. No, this is all about single inheritance. Yes.
So these hours, do you have some time or?
Okay. No, I can talk to you after that. Yeah. I know you want to talk to me, right? Yeah. Don't worry. So I will talk about some concept related to remote procedure call. I will talk about some related to remote procedure call, which is the topic that zero.
Tell me, it's JSON RPC.
Yeah, JSON RPC. Yeah, RPC stands for remote procedure call.
Can you go through what that is?
Yeah, I mean, I covered that last Friday. I think let me check my video because it's depending on how much you already learn from the lecture, but let me take a look at yeah, I'm pretty sure I cover in the lecture 16 and 17. They're both about remote procedure call. I start to give the example in the, so I already upload the code. So CPP07 is JSON RPC, which is remote procedure call. CPP08 is what we call remote object. It's also based on remote procedure call. And CPP09 is about proxy object, which is also on top of remote procedure call. So take a look at the video if you haven't done so. If you have any questions, specific question, you feel free to ask me anything about remote procedure call. Okay. All right. All right. So the second topic, I just let you know, I'm trying to, this is recorded and I'm being recorded. I'm talking about the concept I'm going to ask this Friday. So the first is a virtual function. The second one is a remote procedure call. Okay. I will say those are probably the two things I will focus. Okay, two things. There might be another concept I forgot to mention. I haven't made up the question. I typically made up the question on Wednesday. Okay, especially when you guys ask me questions that usually introduce some creativity in my mind about how I should make up the question. Yeah.
Will
Yeah.
you discuss the midterm in the class tomorrow? Or?
I might, you know, what I typically will do is if I made up the midterm before the class, I will kind of cover some of that as well. Okay, but I also want to move forward to the next topic.
Okay.
Yes.
So I have a quick, I was reviewing the lectures yesterday and
Okay.
looking over specifically
Uh-huh.
so shadow objects.
Mm-hmm.
I guess just conceptually, I guess I'm just a bit confused on how are they different, because from my understanding, remote objects, that basically means the client is talking to the server.
Mm-hmm.
Obviously, the programmer doesn't know where the function is going to, so it's a remote because server can be somewhere else. But how does shadow, like how do proxy objects come into? I'm a bit confused.
Right, right. The difference, to be honest with you, is very subtle. It's very small. But the important difference I try to lay out is that in CPP08, when you make a call, the programmer still need to know where the object is. They still to know. I mean, let me. I'm actually presented in the video now. So if you go to CPP08, if you go to RO client.cpp, which is remote object.cpp, and you will see that if I'm a programmer, I want to make a call. You can see that I have to configure the client. You see that there is a my client over there. And then I have to configure the client so it will go to the other object. Okay, it will essentially what's happening is the difference between CPP08 and CPP09 is in CPP08, I invoke a function that's exactly the semantics or syntax of a JSON RPC. So in the JSON RPC, you define the function called dump to JSON, and then you have a client. You use that JSON RPC interface to call the function. So if you look at the function about dump to JSON, it has 3 arguments. You have three arguments, but you think about the way we define dump to JSON. Dump to JSON has a zero argument. Okay, so essentially we change the interface in the way that the interface is designed for JSON RPC, not designed for the class that the programmer want to deal with. Okay,
In CPP08.
that's CPP08. Okay, but let me in the screen you can see that now I'm going to CPP09.
Wait, I'm sorry, really quick. So in use for CPP08, we have the parameters because the programmer has to specifically define what they're calling for.
Not only they're calling, but also provide some parameter like a class ID or an object ID.
That we usually don't have to.
Right. So if you look at the same thing in the let me do the dump to JSON. If you look at the CPP09 PO client.cpp, and when I call dump to JSON, it's just exactly the same interface, just the object and then dump to JSON without any argument. So you can see that when I make a call in the CPP09, that call is identical to whatever I'm doing without remote procedure call. So that's kind of transparency I was talking about. Is like, oh, the programmer really doesn't need to know that whether that object is a remote or local.
So that's why it's called a proxy object.
It's not only the proxy object, it is a proxy object, but the thing is that the programmer doesn't even know if it's proxy or not. It is a proxy, but the programmer, when they call it, because the interface looks the same. So essentially, when I write a program to invoke any function on that object pointer, I have no idea whether it's going to behave as a local object or as a remote object. And that is why the virtual function is being implemented, such that virtual function can provide that kind of hiding or polymorphism and such as. So that's the big difference. So if you look at CPP08, if I show it here, is the same function for, let me actually just go over here to compare this to, of course. Okay, you want to move over here? So you will be recorded as well.
Oh, that's fine.
Okay, so you can see that I'm calling a function. This is CPP08. That's our remote object. You see, when I call dump to JSON, I have to put 3 parameters here, right?
Yeah.
But when I call this, it's a CPP09, it's a proxy client. You see, this is the way I call. This is the same interface. And you see, from the programmer perspective, if I want to do this, that means programmer need to explicitly aware
Say what
that is the remote object. It's not only he has to use a different interface, he will need to know that this is a remote object because the interface is different, right?
Okay.
So the programmer has to know. But the thing is that over here, the programmer doesn't even know this. What is this GPS pointer?
So,
yeah.
Sorry to cut you off. So then shadow objects, those are typically used as, those are a proxy object, correct? And
That's proxy object,
are those
right?
for virtual functions specifically?
It is a virtual function.
Okay.
If you go over here, let me just tell you. Sure.
I'm going. So thank you very much.
You're very welcome.
Yeah. I'll see you on Friday.
Okay, sure. Hopefully Wednesday.
Yeah.
Yeah. Just want to make sure that we have a, you see, this is a shadow object.
Yes.
We define 2 functions, set GPS label and dump to JSON. They're both virtual function.
Okay.
So virtual function, if we look at the inheritance hierarchy is
That's the
what?
grandchild, right? Of
Yeah, the
GPS,
yeah, right. You see that?
uh-huh.
Is inherit from label GPS, right?
Okay.
Okay, so I need to connect my power cord.
Oh.
Yeah, because I'm running out of battery. Second.
I have a charger. There you go.
No, I have a charger. That's happening. You have a question? Okay, just leave it there. Thank you very much. You're welcome. All right, Now I feel safer to continue. Okay, so there's a bunch of concepts we define here. So one of the concept is about virtual function, which provide polymorphism.
Yeah.
There is another concept that's important over here is whether I can write a code such that I can separate the issues the programmer need to deal with. So I will say the main difference between CPP08 and CPP09 is that CPP08, I expose more information about the object, such as the locality of the object, to the programmer. But CPP09, I kind of separate that. So the programmer, when they call a object, they don't have to worry about whether this, because if you use different interface, that means you have to know when to use that interface. That means you have to know where is that object, right? So you have a different, but when I use only a single interface, then essentially that provide abstraction. So the programmer just use it without even worry about precisely what it is, but they can do programming. Okay. So this is not exactly the same as a virtual function or polymorphism or even proxy object. I would say the three concepts. Let me use this.
Yeah, because that's where it was kind of confusing me because they're all used in different ways, but they're kind of similar in terms of interface. So I was just confused on that.
No, I want to, let me see, do I have, okay. So there are really three concepts. One is called virtual function polymorphism. One is called proxy object. Okay, I call it proxy or shadow object. The other, I will call it programmer transparency. Okay, so you can see that there are three concepts: virtual function and proxy object shadow and the programmer transparency. So there are three different concepts, but they are supporting each other.
Yeah.
So virtual function is it's provided by the language. It's a language feature. Okay, it's a language feature that provided by pretty much every language has this. I mean, every language has some way to represent polymorphism.
Yeah.
In C++, it's called virtual function. But then I'm using virtual function to implement proxy. Okay, so implement this concept called proxy object. Like I'm using that and such that the proxy object is helping me to separate the concern of locality of the object from the content of the object. Okay, so the difference between locality, the content of object is GPS or whatever object you can define, but the locality is basically where this object was stored. Okay, so proxy object allow me to do this separation. And the thing is that then this is related to the programmer transparency, meaning that does the programmer I would say, does the programmer need to know the locality of the object? Essentially, that's programmer transparency. So in CPP08, the answer is yes, they need to know. Because the interface, for example, to interface to call dump to JSON is different. Okay. Different than the normal. Okay. However, in CPP09, the answer is no. the programmer doesn't need to know because the interface is the same.
But they both produce the same output, correct?
Yes, they both produce the same output. Yes, they produce, but they're using different way to
Okay.
call. Yeah. So it's the difference is really the programmer transparency.
Okay.
And sometimes programmer transparency is very important for object-oriented programming because the least the programmer need to worry about, the more he can focus on the logic, the issue that he try to ask the object to do something. It's almost like when you, okay, this might be an interesting example. If you go to Amazon, you try to buy an apple. So you're seeing the apple on your screen. You say, I want this apple. Do you want to worry about where the apple really is, where they're coming from? That is transparency. Sometimes we do, right? We want to know how it's being transported to us. And sometimes we just don't know. We just want Apple. I mean, I'm going to take the ecs36b midterm number 4. I don't care where you get Apple. I want to eat the apple. Okay, it's pretty much that's so. So I'm not saying that programmer transparency is always a good thing, but it's a different option. But typically, it's a good thing. But let me tell you that on the other hand, programmer transparency sometimes is considered a negative thing, especially when you want to deal with performance. When you want to deal with performance, if the thing is like 7 hops away, that is obviously waste your the network bandwidth, your response time. And then a typical computer science major, you need to go deep to unveil that transparency, and then so you can write a more efficient object-oriented program. But typically, my suggestion is the first version we develop is always try to as transparent as possible, and then we recognize the performance bottleneck, and then we do something a little bit different. Okay, you have a question?
What is the locality?
Locality means that where is really the object? The object is on this computer, or is on Amazon, is on Google, or the object might be move around. You know, it could be in Palo Alto's Google server. Now it moved to another server in Sweden. Yeah.
You said that the locality makes a difference for virtual function, or is that only for like classes? Because you were talking about
When I say locality, I mean I use virtual function to implement the proxy object, which essentially help me to hide the locality information.
So if we had a proxy object, wouldn't it be the same? I'm just confused why we're using virtual quantities.
Okay, the reason, okay, can you come over here to take a
Yeah.
look at this example? Let me just kill this. If I go to CPP09, if I do PO client, CPP. Okay, so in this line, I'm calling GPS pointer to the dump to JSON, right? If you just look at this line, I didn't show you anything else. What do you think where the object is? We don't know, right?
Yeah.
So essentially, what is the GPS PTR? GPS PTR is a pointer to GPS DD. And why I say it's a virtual function, because if this object was originally created as a shadow GPS object, then the virtual function is going to call the dump to JSON implementation that's in shadow GPS. That's why we're using virtual function mechanism to help me to hide the locality.
So the locality includes which class it's in as well? Is that what you're saying?
The locality pretty much is just saying where it is in terms of the IP address.
Okay.
So every machine has an IP. In fact, it's a URL. It's not just IP address, but IP address plus a port number, which we use the URL, the HTTP link to represent.
So here you're saying that we have the virtual function make sure that write dump to JSON implementation is called
That's
for
right.
the object.
That's right.
How does that help us protect the locality?
Because we put the locality related information in that virtual function.
Okay.
Yeah, so let's take a look at it. It's a good question. So let's take a look at the,
But depending on which dump to JSON is called, that locality will be called.
right, exactly. So if it's not a shadow GPS object, it's a local object, it's going to call the local object. So take a look at the shadow GPS. You can see here, we have a dump to JSON, right? So the dump to JSON is basically using the URL.
Mhm.
The URL, by the way, the URL was configured when I create the shadow proxy.
Okay.
The proxy already have the URL, class ID, and object ID separately.
Mhm.
And then when I call it, then I'm using that information to call my client that dump to JSON. So this part is the same as CPP08.
Okay, so each class has to have its own like specific locality, or it can,
Shadow.
or like, yeah, so you can't change, like, you can't have the same class in like different places, or like, I don't know if that question makes sense. Because
What
you're
do you
saying,
mean that? the
so
same
you're saying that shadow GPS, when we do the dump to JSON implementation for shadow GPS, the information for where that object is, its locality, is in the shadow GPS object, right?
Right.
So we can't have that object be in different places in one implementation.
Oh, that might not be true. Let me give you an example.
Mhm.
Okay. So for example, I have the same object,
Yeah.
but I have, let me say that object is a video, a
Mhm.
movie. What
Yeah.
video? Pick one video, your favorite video,
A highlight video.
a highlight video. I never saw that video. Yeah.
Okay, let's say your last lecture.
Oh, my last lecture. Okay. So assuming my last lecture is an object, this object is called YouTube video object, right?
Yeah.
So somehow I create two versions.
Yeah.
One version is a rated PG, okay? Assuming I get rid of something, so it's rated PG, and I store that in UC Davis server.
Yeah.
But then there is another version of my video.
Mhm.
I actually store it in somewhere in Netherlands. Okay,
Mhm.
it is a rated R for some reason. Okay, I didn't cut certain language. The language was so offensive, so it's a rated R. It's the same object, but it has two different a copy in two different places. And now when Jonathan, right?
Mhm.
When Jonathan tried to create a virtual object, and then for some reason somebody said, no, Jonathan, you're too young. You cannot see that rated R movie. So your proxy object, the URL will configure to the UC Davis version.
I see.
Okay, what's your name again?
Alex.
Alex. When Alex watched it, and Alex was working for the whatever the police department. They want to actually policing every content. So now he got to access the URL is different. So you can see that even the same program, you might have two different proxy for the same content, but you can potentially direct them to different copy of that information, or different copy in the sense that it will have different representation.
So then in this scenario, proxy is what leads you to the end object,
Right,
correct?
right.
So
And by the way, you might have multiple layer of proxy. You might need to go proxy number one. The proxy number one might say, hey, I don't know how to handle this. I want to deliver this to police department. Alex is working for him to decide who should actually look at that. I mean, you can make it complicated, but the simple one I give is only one layer of proxy, and one always go to that one. But this architecture allow you to have a lot of flexibility.
So it would be like a second layer
Right,
of proxy that decides like which URL to
Right,
configure it to.
right.
Okay.
You can do that as well.
and that's
Yeah.
what shadow is, correct, in our
Right.
function.
In fact, this is actually what happened today. A lot of content is being look, so for example, some of the, you can see that some of the server, you want to access the Netflix movie. The Netflix is going to check
Yeah,
where you're coming from to decide whether you are allowed to see certain content,
yeah,
right? So this kind of thing is actually happening for content delivery and content classification. Yeah. So it's really just different layer of proxy. They do this kind of check. Yeah. Yeah. Talk about Netflix. Netflix locality. Yeah, I don't know. I shouldn't say something which while I'm a customer of Netflix. Yeah. Okay. Any other question? Related to so I would say um for the concept, by the way, what's your name again? Manutri? I remember I learned how to spell your name yesterday. Yeah, I still need to relearn. So we're talking about what's the concept that's going to be asked in the midterm number 4. That's why I record everything. Okay. Okay. Any Alex, Manutri, or Jonathan, or
Yeah, or
Foran? Yeah, I only remember it started with F.
That's
Okay,
enough.
I need to know the second letter. FA or FO?
FO.
FO. Okay, not FA.
I
Okay.
had a question.
Sure.
So for the JSON RPC, like the server creation,
Mhm,
the like the RO server.cpp,
mhm.
is that generated by JSON RPC? Or is it only the .h file?
Only the .h file.
So like this all has to be filled in like ourselves.
That's correct. I do want to just that's a good question. I want to just tell you, let's go to CPP08. Okay, you're talking about CPP08, right?
Well, yeah, but it's the same in all of them, right?
Right.
Because
Let's take a look at our server .cpp. Let me tell you a little bit trick. Okay, so this part is pretty much standard. The first few lines, they're standard.
Mhm.
Okay, this part is more of my I have to create it. This
Yeah.
part. Okay, but here this part is pretty. Even though this part, it looks like I have to fill in this,
Mhm.
but I actually copy everything from RO server.h. So RO server.h is the generated.
Yeah.
So if you look at this part, the last 2 line over here, you get rid of the inline. Okay, inline is not need to be included, but this 2 line is essentially how I copy over there. And then did I talk about pure virtual function?
A little bit.
A little bit, right? This is a pure virtual function. So I basically copy this 2 line over here, remove that equal to 0.
Mhm.
That become the pure virtual function part of that.
Wait, is it still pure virtual if you remove equal to 0? I thought you have to keep that.
No, this one is
Pure.
equal to 0. But take a look at this class. This generator class is called RO server, right? Okay, this is inherit from JSON RPC abstract server. So our server is generated. And then over here, you see that my our server inherit from our server. So essentially this one inherit from this one. So that's why I kind of copy the interface over here. I have to have this because these 2 are pure virtual. So I have pure virtual meaning that I mandate that any derived class from me must have this 2 function. That's really what pure virtual means. Yeah. Yeah, I think I might ask question about pure virtual depending on my allocation of about the question, because I don't want to ask you guys too many questions. I can only ask about 3 to 4 questions. So that's why I would need to select whatever I want to ask.
So then, since this is inheriting from RO server,
Right.
and it has to have these 2 virtual functions,
Right.
would these 2 virtual functions be considered pure virtual, or no? Only the
No,
ones that I inherit?
only
The original ones.
original is a pure
Okay.
virtual. So number 1, how do I specify that is a pure virtual? It has an equal to 0. Okay. that essentially saying that, hey, it doesn't exist, so that's why it's equal to 0. However, that has from the compiler perspective, it says that, okay, any derived class, you have to have a real function with the same interface.
Oh, to define it for the pure
Right.
version. Okay.
Yeah, because that is a pure virtual, that means it doesn't exist. I have to have that. So think about pure virtual, it's just a mechanism to enforce everybody else to implement your own version. And I don't give you a fallback position. If I don't say pure virtual, then you don't have to specify that function, because whenever you want to do something, it will call my implementation. But I want to declare I don't have an implementation, which means that you have to implement yourself.
And let's say GPSDD has a pure virtual function.
Mhm.
Does that mean it has to be defined in labeled GPS, or
Yes.
could shadow GPS?
Yeah,
also
they have to
They
define
both
at
have
least,
to.
well, in that case, if label GPS already have the definition,
Okay.
then that's okay.
Okay.
At least one of them have,
Okay.
I mean, pretty much, I should say that the class immediately derived from the pure virtual has to have an implementation. And then if
So
he,
shadow can't have it for GPSDD because that'd be 2 layers down.
right, there will be two, it doesn't, it might still need to, because the programmer's purpose, but it doesn't have to from the pure function,
Okay.
pure virtual function perspective. Yeah. Okay. Right, any other question? Thank you for all the excellent question. Your classmate should appreciate all your question, because you kind of provide a much clearer understanding about both the concept and what kind of question might be coming out.
I think I'm just still confused about shadow and proxy, but I'm gonna just look over my notes again.
Yeah.
It's the first time of being introduced to it, so I think that's why it's confusing me a bit.
Yeah,
But
it is one of the hardest concept.
okay.
By the way, yeah, the whole concept starting with inheritance and virtual function is already very difficult, because you don't need to worry about that before you learn about object-oriented programming. But proxy, I would say, is a really, I like to talk about proxy because it's a really nice way for you to apply the concept virtual function and inheritance into a non-trivial context. Okay, typically you inherit from a book is a dog, or no, sorry, not a book, it's a dog. Animal, sorry, a dog is an animal. Those kind of simple biological inheritance is okay. You know, we learned that because naturally, but there is a non-trivial inheritance hierarchy for this kind of purpose. That's the power of object-oriented programming. You can do a lot like that.
Is there virtual functions in other languages like Java?
I think Java also have I'm sorry, I forgot about that. I thought Java might also have.
Because I never heard about that concept.
Let me ask Google or ChatGPT. Okay, does Java have virtual function? To be honest, I didn't write too much Java program. Yeah, it is. Yeah, virtual function does have a Java. Oh, sorry, Java does have a virtual function. Yeah.
For pure virtual functions, is it like, I don't understand what the pure virtual function does.
Okay, so in some sense, let me clarify this. Okay, there are two things about pure virtual function. Number one, pure virtual function only define the function signature, which means the interface for the member function, but it doesn't provide implementation.
So you can only use the pure virtual function in lower, or like in
Right,
inherited.
in the derived class, in the
Derived.
lower class, right? So it only provide interface, it doesn't provide implementation. So which means that all the derived class, they need to provide implementation. At least the one immediate derived,
Okay.
they have to have an implementation. Yeah.
So if we were to
but there is a one purpose, one reason is that if you think about this, the way I say it a little bit different is that, well, if you say the derived class need to provide implementation, but then I can just ask the derived class to provide the implementation and interface, and then I do not even introduce the pure virtual at the parent class, right? Right. So that is the mechanism they mandate, they enforce the whatever the immediate derived class, they must have this function implement. They want to enforce that.
So you can't just put like a, cause if I just have like the parent class and the child class, can I not just put a function in the child class as like a non-virtual function? Cause you're saying that.
Yeah, you can do that.
Would it do the same thing as like a pure virtual function? If there was only a parent and a child.
If there's only a parent and a child, yes, you can do that.
But the pure virtual function is if we have like the parent and then like maybe a few children and grandchildren.
Right.
And they have.
No. Even if you have a two level, only the parent and the derived class without anything else, virtual functions still make sense because it enforce that derived class to have an implementation. So think about this. I might not make this clearly. The issue with pure virtual function is usually the parent class was developed by somebody else. Okay, it's not your parent and child developed by the same programmer. It's typically was developed by somebody else. And I want you to use my library, but to use my library, you have to have this.
Okay.
Like this. Yeah.
But then since it's a virtual function, if it's defined in the child class, will it point to the data that the child class, the data type of the child class or the parent class? Like let's say
Say it again.
GPSDD has a pure virtual function.
Okay.
Labeled GPS defines that pure virtual
Right.
function. Would the data type be a labeled GPS, or would it still be a data type like dumped to JSON? Would it call labeled GPS is dumped to JSON, or GPSDD's dumped to JSON?
Because if it has to call labeled GPS.
Because it's defined there.
Not only because it's defined there, because you said it's a pure virtual, right?
Yes.
If it's a pure virtual in GPSDD, it doesn't have implementation.
Okay.
So that's why you cannot call there. It doesn't exist. So that's why it must call the label GPS or whatever lower, in the right.
So if I have like multiple children, one parent, they all have to have their own implementation.
Yes, that's correct. Yeah, all of it has happened.
Another, sorry, I had a quick question.
Sure.
In lecture, you mentioned dump to JSON in CPP08 only has 3 parameters because we don't need the label as a parameter.
Right.
Can you please explain why that?
Okay,
is?
sure. Let's first take a look at the let's take a look at the CPP09 because I think that's easier for me to explain. If I go to PO client.cpp, you see that I call 2 functions. One is I call the function set label GPS, but the other I call dump to JSON. Okay, don't worry about proxy, just those 2 functions that in the original member function interface, set GPS label has to have the 1 parameter, which is the label, while dump to JSON takes 0. So the difference between those 2 is 1, right? So now we move to CPP08. When we calling, remember I said CPP08, it doesn't provide the kind of transparency for the programmer. So you have to figure out all the locality related information. So locality information contain 3 arguments. in fact, it's 2 argument, but add another like a function call. So in the set GPS label, it has a 3 argument. Those 3 argument is the action and the class ID and the object ID. Oh, and then you and for dump to JSON, it's the same 3 argument: the action, the class ID, and the object ID. So those 3 were there because you're doing RPC, you're doing JSON RPC. And however, there's different is one, which is the label itself. That's the one argument difference in CPP09. That's why the in CPP08 set GPS label has to take a 4 label, 4 argument, while dump to JSON is 3 argument.
In CPP08,
CPP08.
it has to take 4 because of the 1 from CPP09.
Because the set GPS label needs 1 extra parameter
In CPP08.
But that's also needs 1. That one was the same as CPP09. Yeah.
Thank you.
Yeah, it is the function itself. So that's why sometimes using CPP09 is easier, because it's from the programmer perspective, it doesn't need to worry about 2 different interface. It just need to worry about 1 interface. Okay.
Thank you.
All right. Any other question? Okay. So do you have any question? Okay. Ruben, do you have any question you want to ask? Okay. All right. Johnson, Alex? Forum. Okay, I finally got it. Okay, finally got it. Okay. You have to come to see me more often. Okay, Foreign. All right, fine. All right. So I'm going to turn off the recording and upload. Okay.